So this is the 2019 Higher Paper 1 question 12. This question here focuses on functions, properties of functions and their domains and ranges. Now this one here, the first part of it looks at composite functions. Second part of it is looking at range of values for functions that exist. Now remember, this one here, f of g of x, is talking about a composite function. The way to remember this and the way to think about a composite function is it's a function within a function. So what we're doing is combining two functions together using one as part of the other. Now for part A, determine the expression for f of g of x, what we have to do is know what f is, know what g is, and then figure out how to insert them. Now we know f is 1 over root x, and we know g is 5 minus x. So what this f of g of x means is that we're looking for f of 5 minus x. Now remember, whenever we've worked with functions in the past, let's say we had f of 3, wherever the x was, we substituted in that value of 3. So whatever we want to put into the function here goes in where we have a value that we don't know. So where we have something representing a value that we don't know. So in this case, the x within the square root. So for that x, I'm going to substitute in the 5 minus x, and that means then that my f of g of x is going to be 1 over square root of 5 minus x. So there you go, that's the composite function f of g of x right there, 1 over square root of 5 minus x. Now second part is looking at the range of values for x for which the function is undefined. Now you have to think of scenarios where if something is undefined, it cannot exist. So for example, if I did 1 over x, I know that the range couldn't include x equal to 0 because I'd be dividing by 0, the function doesn't exist. So if I had the function 1 over x, my range would be all values of x except x equals 0. I've got to look at the same sort of thing here, and I've got to look at where it can exist. Now I could say the bottom can't be 0, but there's a condition within the bottom I've also got to look at. Remember, we can only take the square root of a number that's 0 or greater. So that comes into play as part of the square root. However, what I also have to think about is the fact I've got 1 over the square root, so even though I can take the square root of a 0, I cannot have the value being 0 because I'm then dividing by 0. So that's another part of the condition that exists for this function. So what I have to say is that 5 minus x has to be strictly greater than 0. If that's the case, this function exists. If it's not the case, then it can't be there. Now all I've got to do is a bit of jiggery-pokery and manipulate this, and I'm able to say that x has to be less than 5. So this function here exists for any value of x which is less than 5. If I take anything bigger than 5 at all, let's say 5.1, I'm doing 5 take away 5.1, which is negative 0.1, and I can't take the square root of a negative number. So this here means that the function only exists for the range of values where x is less than 5. So that there answers part B, the range of values for x. Now this question here, fairly quick one it should be. 3 marker, 1 for knowing you're doing f of 5 minus x, 2 for getting the solution there, and your third mark comes by knowing is x less than 5 is a range. This part here, even if you don't state 5 minus x has to be greater than 0 and you just go straight on to x is less than 5, you'd still get the mark for that. Okay, so we just have to remember all of these different types of conditions that exist for functions. Remember what happens with square roots. We can't do square root of a negative number. Remember, for 1 over something, we can't divide by a 0. All these come into play and we have to bear every single one of them in mind when we're working with the functions.